Okay. Well, hi, everyone. My name is Tassia Owen, and I work with Globe Observer and Earth Observatory for Kids. Do all the research for this Earth Observatory for Kids. And then I also get to work on the citizen science project Globe Observer, which has been a lot of fun, where we have trees, trees and cloud observations, land cover observations, and then mosquito habitat mapper observations as well. So today, oh, and I did see that there was, there will be some projects, yeah. There was a question about what my degree was in, and I actually have a degree in English and language arts, and then I have a master's degree in earth science or geoscience from Mississippi State University. So I know that's probably one of you guys' rivals because it's a neighboring state. But that means I just really got to study a bunch of earth science. I specifically love rocks. It's kind of my favorite thing. But I get to do a lot of really cool stuff. So I'm a really big fan. I love my job. I can definitely say that I am living the dream. As a former teacher and museum educator, this is really exciting for me to be able to get to do some like science magic with everybody today. So, so I'm going to start you guys working on some of your citizen science journey. Also, I should say that I'm a Girl Scout troop leader. I live in Portland, Oregon, so I'm with the Girl Scouts of Oregon and Southwest Washington. I'm a brownie leader because I'm the proud mama of a brownie scout this year. Soon to be a junior next year. And then I also just really love doing all of this. So it is a really great opportunity for me to step in and do some Girl Scout stuff and engage you guys. So this is one of the first times I've tried doing any of the citizen science journey online. So we'll see how this works. So we are going to practice your observation skills today. So I'm going to do a little science demo that is a fun one for me. It's called Cloud in a Bottle. So maybe you've seen this one before, maybe you haven't. But all I need is a 2-liter bottle. So you could do this at home. It's just empty, make sure it's not full. And then also some rubbing alcohol and just a splash of it. So I'm going to put a little splash of rubbing alcohol into my bottle. Oh, maybe a little bit more. And then I am going to swirl it around. Just like this. And we are looking at about an hour, maybe half an hour doing this. Not for this project. This demo will last maybe just a couple minutes. And then the last thing that I need is a bicycle pump. So right here, I just have a bike pump that I have put a hole in my rubber stopper so that I can actually put this inside my 2-liter bottle. You can do this with another thing that I can't seem to find right now, called a fizz saver, I think, where you actually just screw this onto your lid and it acts like a pump if you squeeze it enough times. But since not everybody has that fancy device, and most people have some sort of bike pump around, what you do is you put the rubber stopper inside your bike pump, or inside your your 2-liter bottle after you put that rubbing alcohol in it, and it's going to start to evaporate that rubbing alcohol. You can do it in a small bottle, most definitely. You can use really any size bottle. This one's just one of my favorites too, because I also put a thermometer on the top of it. So if you can see, it's about 68 degrees in here. It feels a little bit chillier than that though. And what I'm going to do is I'm going to pump some air into my bottle. But first I'm going to put on my safety goggles because safety first. And usually I would do this with a friend and she would hold this side real tight into the bottle so that we don't have the bottle flying off and hitting anybody in the face or the bicycle pump rubber stopper flying either. So we are going to pump this up. I'm gonna have to keep the pump down here because it doesn't fit in the frame, unfortunately. Whoop. Whoa. So right now you can see that it's still squishy. So as soon as I pump this up, this rubber stopper I got from a science supply store, but good news to you guys, if you have a cork laying around, if you put it in the microwave for about 15 seconds, it'll expand to be the right size to fit the inside of your bottle. So you could just use like a wine cork to do that, and then put a bicycle, or not a bicycle pump, the needle to a basketball pump or a soccer ball pump. If you put that right through the end of it, then it can go right into it and it will work just the same way. So as I pump it up, it gets harder and harder to squeeze. You guys can probably see that it doesn't squeeze much anymore because I'm adding air. So I'm adding a lot of pressure in here. And no, I've never gone to space before. Unfortunately, actually, I'm slightly claustrophobic. So the idea of being in a space shuttle flight scares me. But I'm glad that there are other people that are okay to do that. So when I squeeze it now, it's not squeezing very much. So what I'm going to do is I'm going to let the air out, and that's going to decrease the pressure inside my bottle really, really fast. And when it decreases like that, it's going to drop the temperature inside. And when the temperature drops inside my bottle, it's going to condense the air in it because it gets colder. And when things get colder, air gets cold, it condenses, which just means that the droplets inside get closer and closer and closer together. So we're going to get it closer and closer and closer together until it forms a cloud. So when I do this, I want you guys to use your observation skills. So that's like any of our senses. So we're probably not going to use our touch or our taste or our smell because, well, we're on the computer right now and that doesn't work very well, but we can use our eyes. So we're going to make some observations. If you guys have any observations that you want to share about what happens here or that you've noticed as I've done this, you can just type it into that chat window, okay? All right. Yes, and I will open this up to people to ask questions later. So this is great. All right, you guys ready? So 3, 2, 1. There we go. We made a cloud in a bottle. So if you notice my observation skills, I can look on here and the temperature actually got a little bit colder. You can see that that blue on the 64 degrees is actually much more vibrant than it was before. So, and even that 61 is starting to turn blue. So it's actually getting a little bit colder. And this is just a thermometer from like a fish tank. So you could do that yourself too. So this is a fun experiment. You guys can do it at home. It's a really simple. And I will put in the chat a video or a link to a YouTube video that has me doing it so you can share it with your family or friends. And then also there's a link to the activity that it comes from, which is part of that Earth Observatory for Kids. So if you go to that link in the either of those links, you'll be able to see the video, and then you can also download the article that tells you about how NASA looks at clouds from space. And then you can also do that activity in there. So it's all outlined for you. So ooh, when you release the pressure, the droplets seem to release from each other in a way. Do you mean after it had been out for a little while so that it's starting to equalize with the air around it? Yep, that is definitely an observation. Any other observations? I mean, if we're watching it right now, I'm going to make an observation. I can see through it much better than I could right after I did it. So some of that is all coming out and starting to equalize into the air around us. Yeah, it does. It starts to fade. So all of those water droplets are no longer condensed because it's starting to heat up to the room temperature that's around it. Yeah, pretty cool. You guys are making some really great observations. Oh, I love this. It looks like, oops, I lost that one. It looks like you could see air come out, and right when it shot out, the pressure or the inside of the bottle got cooled and foggy when you first showed it to us, and there was steam coming out. Yeah, those are awesome observations. You guys were definitely paying attention, and I really love this. Oh, and no, you're right. It's not really magic. It's science magic is what I like to call it, because it seems fun and magical, but you're right. It's science, and that's how most of them work. Ooh, how does the air feel that is coming out? Is it hot or cold? It's cold. So if you do this experiment at home and you stick your finger in after you do it, you'll be able to feel that the temperature inside the bottle is a little bit cooler than the air outside. Oh, yep, and now it's gone. Oh, but why is it cloudy? So when all of those water droplets that are inside the bottle condensed, they got closer and closer together. And when those droplets are close enough together, it's so close that the light can't get through. So that's why it looks cloudy to us. So that's awesome. You guys are making such great observations. I love this. Okay, so now I have a question for you. We're going to work on what do scientists do. So I'm curious, and I always like to ask the question, and if you guys want to write in into the chat, what do you think scientists do? Anybody have any idea? And yes, Michaela, there is water in there. So there's water all around us in the air. So you don't see it, but there's tiny little droplets of water all over in the air. So there was water inside the bottle, and that's what condensed to make that cloud. Oh, so scientists use technology to advance our use of anything. Ooh. Oh, you guys are moving real fast. Scientists solve problems. They do experiments. So what do scientists do, B? That was the question. They observe. They study natural resources. And well, and they do a lot to solve things. Awesome. Yeah, that sounds like a lot of what scientists do. But scientists use, wow, you guys are amazing. I love this. They find cures for diseases. Yeah, there's a lot of different types of scientists, but the one thing that they all kind of have in common is that they use this thing called the scientific method. So that just means that they have these steps that they work through so that their science is valid and that it can be replicated so other people can test it. So the first step in that is observing. So scientists need to observe what it is that's around them so that they can come up with really good questions. So you guys did a really good job of observing my cloud in a bottle, and then you guys answered a bunch of really great questions. But after they observe, they want to make more questions. So if you say noticed something like, oh, I noticed that it's warmer when the sun is directly on me as opposed to when the clouds are in the sky. Then you can make a question out of that. Like, well, so why would it be that the clouds make it so that it doesn't feel as hot? And then you would make a hypothesis. And my hypothesis for that, which is my answer, would be, well, I think it's because the rays of the sun are warm and the clouds probably block the sunlight from reaching the ground and making it warm for us. Yeah, so they're making that hypothesis. So, but then it leaves the scientists with the question of, well, how do they know if the hypothesis is correct or not? And that is what leads into the fun part of analyzing and collecting data. So the more data that scientists have, the better their results will be, because it helps filter out some of the outliers or the mistakes or errors or oddball data. So for example, if I was doing science and I was doing an experiment where I would measure how high I can jump. If I tripped on one of my jumps, I may not even leave the ground. So that would be a mistake. It would be an error. It wouldn't be really reflective of how high I can jump on average. Or one time, I might have been freaked out by a crazy chicken and I would have jumped really high, but that would have also been an outlier. It would have been a time when that's not really reflective of how often or how high I really can jump. So if we have more and more and more data sets, so if I measure myself doing it 3 times and 2 of those are outliers, it's not going to really be a good reflection of really how high I can jump. But if I measure myself doing it like 100 times, those crazy outliers just kind of get pushed away because they're not as frequent. So that's why it's really important to take a lot and a lot and a lot of data. So with that, NASA scientists really rely on a lot of data. We joked that sometimes that we were doing big data before big data was big data. because satellites take a lot of data, and it's stored in huge, huge amounts of computing space. There's a satellite mission I work for called Terra, which is celebrating its 20th year in orbit, which is insane. And it's still collecting really wonderful data about our Earth. Some of it's even about clouds. But when Terra first started, the computers that were tracking that data took up entire rooms. And since they have been able to figure out ways to make the data smaller so that it doesn't take up as much space, like physical space, to hold all of that computed data. So scientists really rely on a lot of data because we want to make sure that any kind of outliers or mistakes or things are being filtered out by having all of the all of that time, or all of that other data overpowering those weird outliers. So this is where citizen science is so important. So citizen science allows people just like you, just like my children, just like my grandparents or my parents, to go out and take data that then gets put into a database that can be used to come up with these different, explain different hypotheses that other people are having, especially in the science world. So I work for a program called Observatory, which is a citizen science app where people can go and take cloud observations, tree observations. They can take mosquito habitat observations, and land cover observations. But part of that is also classifying it. So the citizen scientists get the opportunity to not just collect the data, but they also get an opportunity to analyze some of that data. And that data is also available to different groups so that they could go in and analyze the data as they need it to. So I'm going to share with you guys on my screen. Oh, there it is. This is the globe visualization system. So all of these here are different data sets that people have taken. And this was in 2009, I guess. I just arbitrarily have a number there. But you can see that there's a lot of data sets, which makes it that much better. So we've got all of that data that is able to help us get better. Whoop, I think I lost you guys on my, there, it's back. Okay, sorry, my screen did something crazy. All of those data sets, which is really important for getting all of the right data. Oh, and it seems that mine has frozen a little bit. Well, that's okay. We'll go in and talk about maybe this. Yeah, this will be good. So this is an elementary school in Oklahoma that has been taking measurements of cloud data for quite a while. Oh, hang on. I hear people coming and joining us, and I can't seem to be letting them in. Apologies, guys. We'll have to figure that out in just a minute. They pushed an update for Zoom just before I started this meeting, so I'm so sorry if things aren't working exactly correct. But all of these are different data points. So that's a lot of data that this one particular site has taken. And the cool part about clouds is that they change every day. I mean, they can change within the hour as they pass by, and sometimes within the minute. So it's really cool that you can take all those different data counts. So this is how they look in a spreadsheet, which scientists can then use to determine what's been going on, because they have all of the data that they can use to make graphs and analyze that data. So this data is available, and all of your citizen science data would go into it. All right. I guess I just can't let people in while I'm sharing my screen. Well, that's too bad. So I see that there is a question here from somebody that is asking how long I've been at NASA, and I have been working in this job for 8 years now. It's changed a little bit, and Globe Observer just started as my job about 5 years ago. So we just celebrated our 5th year working doing the citizen science project. So it's been very, very fun. So like I said, all of that data is really important. So that's why we collect and analyze data, and why your data is so important, because you could be citizen scientists collecting all that data for other people that need it as well. But I'm going to give us the opportunity to analyze some data that's been collected by globe observers. So let's see, and I get to share my screen again and hope that this works. Share screen. And where did it go? There it is. Okay. So hopefully you guys can see my PowerPoint slides here. Play from start. So this is a cloud identification chart. So this is how scientists classify clouds. So you can see up on the top right here is contrails, which are the streaks that are made from airplanes as they fly overhead, and the air condenses. I'm sorry if you guys can hear some screaming. My children are also home being homeschooled recently, so I think they might be in the background. So those are the different different types of clouds that come behind airplanes. And it's just because when the water droplets that are behind the airplane hit the airplane, they condense and they make those clouds behind them if the temperature is the right temperature for them to be produced. High in the sky, we have different types of clouds called cirrus clouds, and they're just the really wispy ones that are really super high up, and sometimes they're made out of ice crystals, so that's a pretty cool thing. And then there's cirrocumulus, which is those white fluffy clouds, but they're really up high. And these cumulus clouds right here below it are altocumulus, which is alto just means middle. So our sky is divided into basically three sections that we talk about when we talk about clouds. Stratosphere, or the strata clouds, are the ones that are on the lower portion. The alto clouds are the ones that are in the middle, and then the cirrus clouds or cirro clouds are the ones that are way up top. But they all can be a little bit different. So the wispy ones for the cirrus clouds, the cumulus clouds are those white fluffy ones that are like the happy little clouds. And then the cirro stratus clouds, stratus just means like blanket. So if you think about it as the entire sky kind of looks like one color, that's a stratus cloud. So altostratus is like that gray, dreary, overcast day. And then stratus clouds are really when it covers basically the whole sky nearby you. And then we have some convective clouds as well, which you guys might recognize from different storms. And those cumulus clouds are actually convective clouds because they can rise up high enough and become a cumulonimbus cloud. And nimbus just means rain. So if you see this nimbostratus cloud right here, that's just a rain cloud that covers the entire sky. It blankets the sky like those cirrus clouds. All right, the other things that we look at are sky color and visibility, cloud cover, and cloud opacity. So sky color can tell us about how many particles are in the air. So if it's like a really hazy day, that might mean if it's really hot and hazy, we might have a lot of particles that are in the air that are making it hard for us to see through the atmosphere. But if it's a really crystal clear blue day, then there isn't probably a lot of that haze or particles that are in the air, whether they're water vapor or dust or smoke. It could be a lot of different things. And then we talk about cloud cover, just how much of the sky is covered in clouds, and then cloud opacity as well. All right, so here we go. So right here, you guys can put into the chat, what kind of cloud do you think this one is? All right, and I can't actually see the chat when I'm sharing my screen, so I apologize for this. So hopefully one of you guys said cirrocumulus. If you said cirrocumulus, you are correct. It looks just like this one up here. All right, we're gonna do this for a few more. Ooh, what about this one? Nice and wispy. Did anybody say cirrus clouds? That one right up here. So those ones are really high up in the sky and sometimes made out of ice crystals. Ooh, what about this one? This is one of those convective clouds, the cumulonimbus clouds. So you see how high it goes up into the sky. Yeah, because it means that the temperature up there is unstable. So it changes a lot, which makes the clouds form really, really high up. Oh, what about this one? Okay, cumulus clouds. Yeah, so it's just like these fluffy ones right there. What about this one? Yeah, it was a trick question. It's a cumulus cloud as well. All right, and then this one. Does it look like it's raining at all? Is that a hint? And it covers the whole sky. So if you said nimbostratus, you're correct, because it's a raining full blanket of a cloud. What about this one? I don't think it's raining. This is one of those stratus clouds that are really like just on the horizon and they cover the whole sky. So if you see gray skies, it's a stratus cloud. What about this one? There's no clouds, so you can't classify them. So this would be one of the times where we actually look at sky color. And notice that this one's that deep blue, which means, and it's probably very clear. So that just means that there's not a lot of particles in the sky. All right. Thank you for playing your cloud classification game with me. Oh, and there was a few people that didn't make it in. Sorry. So welcome. So that is one of the things that scientists do is they'll go and classify those different types of clouds or different data that come in. So you always have to be analyzing the data that you get. So as a citizen scientist, you can actually analyze that data as well. And it's really important because it goes into those spreadsheets that I showed you earlier so that scientists can filter by what kind of data is that they're trying to look for. So it's a really important way of being able to make sure that we're looking for the right stuff that's needed for the research that's being conducted. So I have a video that I was going to share with you guys. Let's see here. I can get it to share screen.
Hello, Girl Scouts. My name is Kristen Weaver, and I'm an outreach specialist with Science Systems and Applications, Inc., working out of NASA's Goddard Space Flight Center in Greenbelt, Maryland. My job is to take all of the cool science and engineering that NASA does and help make it easier to understand for the general public, as well as find ways for people just like you to contribute to NASA's science work through citizen science. I would also like to say that I was a Girl Scout when I was a kid, so I'm really excited to be involved in this partnership in particular. One of the projects I work on is called Globe Observer Clouds. NASA has many satellites orbiting the Earth that look at clouds from above, but we need your help to make matching observations from below. By getting the perspective from both sides, we can have a more complete picture of what's happening with clouds in the atmosphere. It's important to know not just how much of the sky is covered by clouds, but also which types of clouds are present, because different clouds have different effects on Earth's weather and climate and what we call the Earth's energy budget. Satellites see clouds differently than human observers, and NASA scientists could never be in all the places they would like to be to collect data from the ground, which is why we need your help making observations. Here's what we need you to do. Download the free app on your cell phone or other mobile device and set up an account. Check the satellite flyover times for your location, and if you can, go outside to make an observation within 15 minutes of that time. You can make observations anytime, but the most useful are near a satellite overpass. Then, just follow the directions to look at cloud cover, cloud types, and conditions of the sky like sky color and haziness. We'll also ask you about some things that can affect how satellites see the clouds, like whether or not there is snow or ice on the ground. The final step is to take pictures of the sky in all directions, and then send us your data. Thank you for helping NASA understand our home planet.
So you might have seen at the end there that we are in partnership with SCIstarter. So SCIstarter has a bunch of different opportunities that you can do for citizen science. So you don't have to just choose Globe Observer, although I might be pushing for that because we do need your data. But if you go to the SCIstarter link that I will put in the chat, if I can get my mouse to cooperate, you can go and find out about the different types of projects that they have there. Additionally, it actually tells you how to sign up and get your Girl Scout troop leader to do it. And the name of the app is Globe Observer. I'm going to put that in the chat for you. Maybe I'm sending it in person. My apologies, everyone. So you can go and download the app, and I will put that link in there as well so that you guys know where to get it. But Globe Observer has a bunch of different different tools that you can do. So you don't have to just do clouds. If you're interested in tree height, you can actually use your cell phone and use it like a clinometer, which is a fancy science term for basically a protractor that you can use to calculate how high trees are. So if you're ever wondering how high that tree is in your yard, you could use your phone using the app to actually go out and measure that tree. You can also take land cover measurements and classify them similarly to how we classified the different clouds, but instead of it being clouds, we'd be looking at the ground. So it'd be like grasses or trees or forests or urban, and all of that's really important too. And the reason that we do it is because we can't see the detail in satellite images. So satellites see all right, but they're about a 30-meter pixel. So that just means that the resolution is about the size of a baseball field. So every little square that makes up a larger picture that you would see that looks like a really detailed picture, the tiniest square in it is the same size as a baseball field. So there's a lot of things that can happen in a baseball diamond, right? So we're just going to look, so we use this to make sure that we're seeing all of the other things that are going on in between. So if there's a question in the data, we could always pull up the image of satellite image and put it next to a picture that a Globe Observer has taken to be able to see, like, well, what was going on right there? And the same thing with the clouds, because if you have those high cirrus clouds and they happen to be really thick, you may not see different layers of clouds that are below it. And there might be cumulus clouds on the bottom layer, and there might be some altostratus clouds above that, but we wouldn't know that because the top layer blocks the satellite view. Unless you have special instruments to be able to see through it. And only some of the satellites have those specialized instruments. So that is essentially all of it for Globe Observer. And I really hope that you guys really want to get involved. The nice part about the Clouds app, or the Clouds tool in the Globe Observer app, is I know a lot of people are at home right now, and you don't have to leave. You can take observations through your window. You can take observations from your front door. So it's a really good opportunity to be able to do some of that science and really contribute and work on your Think Like a Citizen Scientist journey as part of helping NASA scientists collect that data that we are looking for to be able to get a better idea on what's going on our planet and understanding how Earth works as a system. And I know that part of the Think Like a Citizen Scientist journey is after you go and collect and analyze your data that you're supposed to do a take action project, which the one thing I love about Girl Scouts is that we like to leave the world a better place. And that's a wonderful thing. And you guys are so amazing to be able to do that. So I would ask you guys, if you were to be using the Globe Cloud Observer app, what would you think of doing as a service project? I have a few ideas, but I'm curious if anybody else has any. You can put those into the chat if you are wanting to share. I can also just tell you a little bit about mine. My ideas is that, remember how I talked about visibility? So how hazy our sky might be, that can tell us a lot about how clean our air is. So I would maybe do a project about trying to educate people in my community about what particles end up in the air. So what comes from their tailpipes and how that might decrease visibility and how smog is created, and doing a kind of educational program. You might also consider doing something like tracking frequent storms that come by your house, because then you would be able to help your neighbors expect what or when to expect a storm and let them know so that if they have things out, they can always put them away. So for example, in my yard, we have some chairs that blow over really easily if there's a storm, but if I knew that there was a storm coming, I would bring them in. So if you're looking, you could even do a short take action project just like that to just be able to help your neighbor. Or you could create a storm kit so that you would be able to help your neighbors if there was a severe storm that hit. Oh, I like this. You guys have some really good ideas. Clean up some beaches. Yeah, you can do a lot. Pick up trash, planting trees and plants. Oh yeah, that's all really important stuff. And so a lot of those too go with the land cover. So you could plant a pollinator garden, and that could be a different type of land cover that you're creating in order to provide habitat for bees and butterflies, and help produce better plants for your neighbors' gardens because they're going to be getting pollinated. So those are all really good ideas. I love this. You guys are so wonderful. I'm so glad to see that you guys are all trying to think of ways that it might change. And there's a question that I did see here that somebody asked if the air pollution will decrease with the global pandemic. We are actually in the process of using a lot of the satellite data that we have to be able to figure that out. There was a image that was out through Earth Observatory, which is part of NASA, a few weeks back about China that showed that NO2, which is a nitrogen dioxide, which is a pollutant, had decreased while much of China was under quarantine. So there is some changes. There's other gases that are longer, they have longer lifetimes. So we may not see those right away without doing a lot of computer modeling and being able to generate the data in a way that it makes sense, trying to take out some of those outliers. Because if something sticks around for a long time, you may not see the effects of it right away. So one of those things is like carbon monoxide has a very long lifetime, or methane, it has a long lifetime. So you wouldn't necessarily see the effects of those pollutants being changed by people not driving and things not being manufactured as much right away. And I don't know. So that is current science right now. And all of that is so important. That's one of the reasons why your observations could be very important as well, because if the particles that they're looking for, like maybe aerosols, which are the teeny tiny little particles from like smoke or dust that are in the air, that which do really impact visibility, that data could come from some of your observations even. So that's basically what I have for you guys. So I am going to open it up for you guys to ask any questions that you want for the next 5 minutes or so. And I am so pleased that you guys joined me today, and this has been really wonderful. I'm so excited to be able to work with you guys. So let's see, any questions? Oh, I love NASA. I love NASA too. Is the heat changing in Paris because of quarantine? I actually don't know. The Terra satellite has land surface temperature sensors on it, part of the MODIS sensor. So that might be something to look into actually. If you're interested in looking at satellite data, there is a website, and I can't remember what the actual website URL is, but I'll put it in here. If you Google Worldview NASA, oops, hang on, I keep responding to people that are asking me things. Sorry, if you go to Worldview NASA, if you just put that into your browser, you'll be able to pull up a interface where you can actually go and look at some of the data for different things like land surface temperature or aerosol data. Oh, I see if somebody asked if Pluto is still a planet. Pluto is not classified as a planet anymore. It's a dwarf planet because it doesn't meet the criteria that they adjusted in the definition for planet. But Pluto did not change. Pluto is still there. Pluto is the same as it's been. It's just that the definition has changed a little bit. Do you design things at NASA? I do. Sometimes I get to design exhibits where we'll work with different museums. I also design the publications for Earth Observatory for Kids, which go out almost monthly. So I get to do a lot of really cool artwork as part of my job as well, which is not something I thought I would be doing, but I'm really love that part of my job as well. Let's see here. What does NASA stand for? It's the National Aeronautic and Space Administration. So we were an agency created in the 1950s as part of the space race. And if you guys have seen Hidden Figures, that'll explain a lot about how NASA really started. So it's pretty cool, and I think that NASA's been doing great things for women for a long time. I'm not on a documentary that I know of, but I'm glad I look familiar. Oh, I see. So if Pluto is not a planet, then why does dwarf planet have planet in it? It's just another definition title. So it's just a little bit of change in the definition again. And I actually don't know how many dwarf planets we have right now in our solar system. It seems to be changing fairly frequently because they're always looking for some. There's also some citizen science opportunities if you're looking for doing some of that. If you go to the Go NASA Science, you can find a bunch of NASA citizen science opportunities that you could explore as well. Let's see. I don't think I see any more questions. Oh, how can you make charts of things by yourself? So if you you can use different spreadsheet apps, so like Google Sheets, you could use Excel. What's the other one? Google, or no, it's Microsoft Notes, I think. I'm not sure, I don't remember. But in there, they can create different charts using the different data that you'd have. So you'd be comparing two different things typically for a line graph, or you could be charting the amount of something, doing a bar graph. So you could do a project where you figure out how many days of the month there was broken clouds in the sky, as opposed to a straight cloud cover. And that would just be a bar graph where you could compare those. But you could get that by that visualization tool that I showed you guys earlier. But cool. Yes, the longer you're in space, the taller you get because there's no gravity to pull you down. So as we age here on Earth, people sometimes get shorter. All right. Oh, do I believe in aliens? I don't know. I believe that there's probably life somewhere else in space, but I don't know what that looks like. I would think that it's probably something small, like single-celled organisms, but I don't know. And I'm very excited to see what we find out as we're working towards getting to Mars and beyond. So I don't know. Sounds great. I think it'd be interesting to find out. Ooh, and then I think this is going to be my last question. There is a question on how many satellites orbit Earth. It's a lot. I don't know the exact number. I think that we currently have 29 Earth observing satellites in our fleet from NASA. So there's new satellites that are going up all often, and there's some that are retiring as well at the same time. So it changes from time to time, but not just us, but other countries have satellites. And then there's also private satellites that are up there. So there's like GPS, which tells you where you're at on your phones, that are also orbiting. And those aren't necessarily government satellites. There's a lot of private ones that different companies use to get data. So that is all I have for you guys. But what I can say is that NASA data, a lot of it is free and open to the public. So we like to make sure that you guys are getting the information too, because we want people to be able to explore and to understand our Earth just a little bit better. So I want to thank you guys all for joining me. This was really, really great. and I will, if you guys go and observe some wonderful clouds and land cover and measure some tree heights and get involved. So thanks a lot. Bye-bye.